Hello, chemistry students. Today we're going to start the new unit, Unit 1, Part 2B of the Chemistry of the Big Bang, and look at the first lesson, which is lesson number 9, talking about the structure of the atom. So this may look familiar to you. It's a pretty common visual talking about how the atom looks. It's a classic where it has the neutrons and the protons in the middle, called the nucleus, and the electrons are buzzing around the outside. We're going to dig a little deeper into what all that means. So first thing, by definition, an atom is the smallest particle of an element that still has properties of that element. So they break it down, 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 until you get to the point where the next time you break it down, you get protons, neutrons, and electrons. The smallest representative particle of an element is called an atom. They're made up of 3 basic subatomic particles. That's the protons, neutrons, and electrons that we're going to talk about in a couple seconds. And there's many, many more subatomic particles. Remember, we talked about quarks in the last unit. So there's 3 videos here that I have linked in the Schoology classroom. One is this, how small is an atom? And then one is the, you can stop now. The next one is this atomic theory, brief history. And then lastly is another atomic theory history. This one is a high school level video from that MIA Academy. All 3 are on Schoology in their own individual pages, and if you wish to watch them, that's great. I would definitely suggest you watch one of the atomic theory videos talking about how the various particles were discovered. But here we're just going to focus on what they are. So first off, there's 3 subatomic particles. There's the protons, the neutrons, and the electrons. And things you should know about them, already probably do to some degree, is first off what their charges are. Protons are positive. They have a positive 1 charge. Neutrons have no charge. They're neutral. And electrons have a negative 1 charge. So the protons and the electrons electronically are opposite in charge, with being +1 and -1. Where are they located? Well, the protons and neutrons, we already saw this, they were in the nucleus. That's in a small, very, very dense center of the atom that Rutherford discovered. All the positives and all the neutrals are in this tiny speck that is incredibly small. And then the electrons are buzzing around the outside, and they can either be in the shells or in a cloud, depending on which theory you're looking at, but they are not part of the nucleus. How big are these various particles? Oh, sorry, let's look at the nucleus. So nucleus is that small, very, very dense center of the atom. It is incredibly small. It's where almost all the mass is, because as far as masses go, electrons have essentially 0 mass. There is mass, but relative to the protons and neutrons, it is very, very insignificant. The nucleus has all the protons and neutrons. The term that's used for things in the nucleus is nucleons. It was discovered by Rutherford in what's called the gold foil experiment. And if you watch the theory of the atom, or the atomic theory MIA Academy, that does a really, really good job of describing Rutherford's experiment. And I would become familiar with that, so I'd watch that video to get a better feeling of what Rutherford did. Here's what they look like now. So you have these shells that contain the electrons, and the protons and neutrons are in the middle. Now granted, the protons and neutrons in this visual are very, very significantly drawn out of scale, is a speck compared to the rest of the atom. Sizes. Well, as far as mass goes, the protons and neutrons are essentially the same size. It's called 1 AMU. AMU stands for atomic mass unit. It is by definition 1/12 of the mass of a carbon-12 atom. 1/12 of the mass of a carbon-12 atom. A carbon-12 atom has 6 protons, 6 neutrons, and 6 electrons. The electrons themselves, they're tiny. Look at that. Almost 1/2000th of the size of a proton or a neutron. Very, 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 very tiny. Translation, you need 1,836 electrons to have the mass of 1 single proton. Very, very small. So looking at relative masses, the atomic mass unit called the AMU, or you'll also see it just labeled as the U. It is a measurement of the mass of the atoms is something that's only used in the atoms. And again, by definition, one AMU is 1/12 of the mass of a carbon-12 atom, and a carbon-12 atom has 6 protons, 6 neutrons, and 6 electrons. We're going to talk about this 12 designation in a little bit. Actual masses outside the AMU, look how small they are. You've got a proton being 1.672 times 10 to the negative 24th grams, and neutron is 1.674 times 10 to the negative 24th grams. So very, very, very insignificant difference between the size of a proton and a neutron. At the 3 significant digits, they're the same. And the electron, look at that, that's very, very small, 9.10 times 10 to the negative 28th grams. It is at 1836th of the mass of a proton. So what does each one of the particles do? Well, the protons identify the atom. So the number of protons will tell you what atom you have. So for instance, carbon has 6 protons, but nitrogen has 7. Adding a proton or adding a neutron, adding a proton or subtracting a proton is going to change the identity of the atom. The neutrons supply the mass that's in the center, in the nucleus, but it also is that thing that provides the gluons that hold the nucleus together. Theoretically, a nucleus should not stay together. You've got all these positive particles. Similar charges repel. They stick together in a very, very tiny space. The reason for that is the gluons that are part of the neutrons in the atom. Then the electrons, that's where bonding is going to take place. Those are on the outside shell. Those tell you they'll interact with other atoms to form bonds. Right now, one of the things we're going to look at in this clip is talk about how we have charges of different atoms to make them ions. Then finally, where do we find these numbers? Well, the atomic number, we already talked about this earlier when we did fission and fusion. The atomic number is a single-digit number, integer number on the periodic table. That is the number of protons. So we already know that. The neutrons we're going to get from what's called a mass number. Mass number, by definition, is the number of nucleons, the protons plus the neutrons plus the protons. Electrons, assuming we have a neutral atom, the electrons are going to be the same as the protons. We'll talk in a little bit about how that changes. So if I need to read a cell on the periodic table, we've done this already a little bit before, but let's break it down a little bit better. Here is this typical cell off the periodic table for boron. Boron is element number 5, so that's the, and B is the symbol. Whenever you have a symbol, I mentioned this before, the symbol is going to be first letter capital, second letter will be lowercase if there's 2 letters. All the elements on the periodic table currently, any new ones get added to it, are going to be 2-letter designations. The element's name is on your periodic table, so you need to be able to spell your element's name. The atomic number is at the top. On your periodic table, it is at the very, very top of the cell, is a whole number, is an integer. That is the number of protons. And then the decimal number, we're going to talk about that a little bit more in lesson 10, but that's a weighted average. It's a weighted average, meaning that it tells you how much the atom, on average, will weigh. And we'll talk again in lesson 10 on how to calculate that. So one of the first things I had to do in this particular lesson was to do the building of an atom FET. And hopefully you got something useful out of that. So let's look at figuring out the number of protons. So if I look at an atom, there we go, that's the atomic number, that number up top, that's the atomic number of carbon. That tells me that the atomic number is the number of protons in the atom. As far as an individual element goes, that does not vary. Every single version, isotope of carbon has 6 protons. If it has more protons, it becomes a different atom. If we're talking about a neutral atom, then the number of electrons are going to be the same as the number of protons because we want to have equal number of pluses and minuses. We have equal numbers of pluses and minuses. The atom has no charge. However, atoms can become charged. And when they're charged, they're called an ion. It's an atom that has a charge, which means it has an unequal number of electrons and protons. What's going to happen in an atom is it's going to lose electrons or it's going to gain electrons. You're not going to have a situation where you're going to gain or lose protons because then you change your atom. So let's see if I can make this work. Sometimes the touchpad is a little fickle, so we'll see how well this goes. So if I'm looking at the atom that is chlorine, let's put it over here, chlorine. Chlorine has 17 protons and 17 electrons. But if I gain one more electron, which means I have now 18 electrons and 17 protons, now it becomes an ion. This would be a chlorine with a -1 charge. That's just saying that it has one more electron than it has protons. You can do the same thing by doing the by losing electrons. Typical example there would be the atom of sodium. Sodium is Na, is element number 11, so it has 11 protons and 11 electrons. But sodium, as we'll find in the bonding chapter, really likes to lose electrons. It will lose one electron. So sodium always have 11 protons, that makes it sodium. But if it loses one electron, now it has one extra proton, so now this becomes a +1 charge. So the charge of the atom is indicative of the relative numbers of protons and neutrons. A chemical formula to try to, equation to help you remember the charge is if you gain electrons, the thing becomes negatively charged based on how many electrons you gain. If you lose electrons, it's going to become positively charged based on the number of electrons you gained. The terminology for the ions is if it's a positive ion, one that has lost electrons, that's going to be called a cation, and the negative version is called an anion. So this sodium here is technically the sodium cation. It is a charged particle that has a positive charge. Another way to look at get the charge or get the number of electrons is to consider that in an ion, the number of protons and electrons are not going to be equal. So you're not going to have the same number of pluses and minuses. And as I just showed you with chlorine, if it had 17 protons and 18 electrons, then it would be -1 charge. The negative, we often in chemistry we use what's called the invisible one. So this is the same as this. Okay, we wouldn't put a 1. Very often we don't put the 1. But you can see if it's positive, this has two less electrons than protons. That becomes a +2. Okay, so electrons you can get based on the charge and the atomic number. Last thing to get is the number of neutrons. Now we mentioned already that the neutrons are in the nucleus, and the number of nucleons in the nucleus is called the mass number. So the mass number is going to be a whole number. And when we were doing our nuclear equations, that was the number that was up top, was the mass number. That's going to be the number of protons plus neutrons. So this means fluorine, this version of fluorine, has 9 protons and 10 neutrons. So the mass number is going to be a whole number. Mass number is going to be a whole number. It's not the atomic number. The atomic number is a decimal. The mass number is going to be a whole number, and when you write your nuclear symbol, it's going to be up here in the top. Or you might call this particular atom fluorine 19. Mean it's the version of fluorine that has 19 things in this nucleus. To get the number of neutrons, you're simply going to take the number of the mass number, and you're going to subtract the lower number. So in this case, like I said, this number of neutrons here would be 10. Next thing on this particular PowerPoint with the structure of the atom is the concept of what an isotope is. So an isotope is a situation where we have different versions of the atoms, different weights. So it says the same atom, so the same element, but you have a different number of neutrons. Have a different mass number. So for instance, carbon 12 and carbon 14 are two of the three versions of carbon. Carbon 12 has 6 protons and has 12 total things in the nucleus. So that means it has 6 neutrons. And carbon 14 has 6 protons because it's still carbon, and it has 8 neutrons in the nucleus. So carbon 12, carbon 14 are two different isotopes that are the same atom, but they have a different number of neutrons. The way you would write an isotope symbol would be with the X and then like the mass number up top and the atomic number at the bottom. And again, I told you when we're doing the other piece that sometimes we don't put the atomic number at the bottom. So let's look at a couple examples real quick before this particular video is over. If I have chlorine 35, it could be written as chlorine 35, Cl35, or if you're writing the words chlorine 35, symbol with mass number up top, atomic number at the bottom. If I want to get the number of neutrons, top number minus bottom number. If I have a different version of the chlorine, maybe I have chlorine 37, now chlorine 37 has 37 things in the nucleus. It's still chlorine, so still 17, but the mass number now is 37. So to get the number of neutrons, it's mass number minus atomic number to give you 20. What if it's charged? Well, here we go. If I have an ion, this is calcium 40 with a +2 charge. Calcium 40 with a +2 charge has 20 protons because it's element number 20. Has 20 neutrons. 40 minus 20 is the 20 neutrons. Then the charge tells you the number of electrons. So if I have 20 total protons minus a +2 charge, that gives me 18 electrons. So this atom, this represented atom, has 20 protons, 20 neutrons, and only 18 electrons. So let's look at an anion. So here's the nitride anion. I've got a mass number of 15, so this is nitrogen 15. Atomic number for nitrogen is 7. So 15 minus 7 is 8. So that means I have 7 protons because it's element number 7. I have 8 neutrons. That's 15 minus 7. And I have 10 electrons. The atomic number for nitrogen is 7. Minus the charge is a -3. So 7 minus a -3 is 10. I have 10 electrons. So you should be able to, after this lesson, be able to understand, know the structure of any atom or isotope, identifying the number of protons, neutrons, electrons, knowing what the mass number is, knowing what the atomic number is, and knowing what the charge is. Hopefully that helped. That's the end of this lesson on lesson number 9.